Assalamualaikum and a very good day to my sir, Encik Hafiz bin Sarkawi. My name is Muhammad FIRDAUS Ameen bin Anuwar, and today I will present about our first lab, which is Laplace transform. So basically this lab we have 8 tables. So for the first table, it is just a mathematical working. So I'm gonna compare this mathematical working with my table 3 later. So I will go straight forward to my table 2 first. So for this one, it's just to declare this number for the numerator, and for this one to declare this number for the denominator, like this 2 3 and 1 5 6. And okay, for the RPK, we can see here the R is 1 2 and P negative 1 and 0. 1 2 is for the numerator, P is the for the denominator, but it will change the pole. I mean, like this 1 over is supposed to be S plus 1. So I can show you example. This 1 over S plus 1, and another one, wait, for this one is 2 and 0, so it's supposed to be 2 over S. So for the example, 2 over S is over here, 2 over S and 1 over S plus 1. For other example, I will okay, this one a second. For the residue is 1 and 1, for the poles is negative 4 and 3, so it's supposed to be 1 over S plus 4, and another one is 1 over S plus 3. So when we see at the mathematical working, you can see here 1 over S plus 3 and 1 over S plus 4. So that's for the table 3. So for the table 4, we are using the theorem over here. For the first one, I open the theorem first. For the first one, is just function for the 5th and 15. This one we're gonna using the theorem number 2 over here, which is it will count the 15 is a constant, so the constant we just put it there, and with the over S, so we're gonna get this 15 over S. For number 2, we're gonna use the theorem number 5. You can see here when the power of exponent is negative, then the denominator we're gonna be positive, so our power here is positive, so inside the denominator we're gonna use the negative. And for the number 3, we're gonna use the theorem number 3. So for the number 3, you can see we have a constant and a function t here, so it will become the constant and over the s square, like this. And for the last one, we're still using the theorem number 5. It's just same as the number 2. So that's for the table 4. And for this table 5, this command is just a shortcut for creating symbol. And the second command is just an equation of f. For this one, the pretty, it will arrange the equation into a better ways. I will show the example over at the table 6. We're gonna see this because this is inside the MATLAB. So you can see the SimST is just display nothing over here. For the function, it will display the function like we do here, and for the pretty part, it just remove the uncertain object, like just like star. So we just exp to t. For the Laplace, we're using the theorem, so it will become like this: 1 over s minus 2, and they simplify things here. Then last one, pretty, it arranged the equation into a better ways, make it prettier. So it become like this for the last pretty part. So for this table 7, everything just same. It just that we have the inverse Laplace over here. It's a bit complicated if we see in this output. So I'm gonna show you inside the MATLAB. Yeah, here. So same as no output, and when we put the function here, it display the function. Pretty G, they will arrange this function from this to this. And inverse Laplace, when you inverse this using the theorem, you will get this 2 star exp in bracket minus t. Then we make it pretty, we'll arrange, remove the star. Like I said, pretty is using for remove the uncertain object. So I think that's all for this lab. Thank you very much, sir.